Okay, example 11 is asking us to find consecutive terms of a geometric sequence when two of them are unknown. Now, we know that geometric sequences involve a common ratio, so the temptation might be to go, I know I start with the last term and divide by its previous one, then I use the previous term and divide by its previous one, and so on. I hope you recognise that that's going to get pretty ugly pretty quickly. We don't actually want to do that because we don't have enough information to solve that very nicely. We need to think about it in terms of what consecutive terms of a geometric sequence actually are. If this is the previous term and R is our common ratio, then can you see that we have to multiply 3 by R to turn it into M? So it's actually going to be 3R. To get from M to N, we then multiply it by R again. 3R times R is 3R squared. To get from N to 192, we multiply by R again. So 192 is actually 3R cubed. And it's this little piece of information that we're going to rely on here. So 192 equals 3R cubed. One equation, one unknown, we can solve for R. We divide by 3 on both sides and we get 64 equals R cubed. And then we take the cubed root of 64 and that gives us R. So R equals 4. On your calculator, there is a special button for cubed root, or the other way you can do it to type into your calculator is 64 to the power of 1/3, and that will give you the answer. So R is going to be equal to 4. So looking at the unknowns expressed in terms of R here, M is actually equal to 3R, which is 3 times 4, which is 12. N is equal to 3R squared, which is 3 times 4 squared, 3 times 16, which is 48. So our sequence is going to be 3, 12, 48, and 192. And you can see there that our common ratio is actually 3 times 4 is 12. 12 times 4 is 48. And 48 times 4 is 192. And that's it.